Escomatic coil-fed automatic lathe, model D2 and D4. Setup operator training system. Lesson number 9, stock feed system. The stock feed system controls the movement of stock through the machine. Timing of the stock feeding is coordinated with other operations of the machine to assure accurate stock feeding. The movement of the stock feed attachment is caused by the rises and dwells of the stock feed cam. The stock feed attachment transfers the stock feed action to the friction clutch assembly. When the friction clutch is engaged, movement of the stock feed attachment is transferred to the upper and lower stock feed rolls. Mounted on the back of the upper feed roll shaft is the friction disc. The purpose of the friction disc is to provide rotation to the upper feed roll. When the upper feed roll is lowered, the friction disc will come in contact with this roller disc on the friction clutch assembly. The roller disc rotates with the friction clutch when the friction clutch is engaged. Pressure between the friction disc and the roller disc surfaces causes the upper friction disc to rotate. The upper feed roll will rotate with the friction disc. The lower feed roll is driven directly by the friction clutch. Rotation from both the upper and lower feed rolls cause the stock to be fed into the cutting tools and drills. The stock feed cycle has two portions, the stock feed portion and the stock feed attachment return portion. During the stock feeding portion of the cycle, the friction clutch is engaged and stock will be fed out. At the start of the return portion of the feed cycle, the friction clutch cam will disengage the friction clutch by moving the hydraulic plunger into the hydraulic control unit. The feed attachment will then be fully returned. After the stock feed attachment has been fully returned, the friction clutch cam will allow the hydraulic plunger to release the hydraulic pressure. Spring pressure in the friction clutch assembly will engage the friction clutch. Stock will again be fed out and the cycle will repeat. Also timed with the stock feed system is the action of the stock straightener and stock clamping jaws. As the stock is fed out, the stock clamping jaws are unclamped and the slide will be in its forward movement. At the start of the return portion of the feed cycle, the clamping jaws will clamp the stock and the slide will begin its backward travel to straighten the stock. The return of the stock feed attachment and the cutoff of the finished part and the backward travel of the slide all occur during the return portion of the feed cycle. These are the grooved stock feed rolls used on the Model D2 and D4 schematics. The feed rolls will have to be changed depending upon the different diameter stock used. Each feed roll is marked with the diameter stock size it can be used to feed. There are different shaped grooves used on the feed rolls. The grooves may be round, V-grooved, or squared. Square feed rolls are used for square stock. The V-groove feed rolls are made with either a 30-degree, 60-degree, or 90-degree groove cut in the feed roll. The V-groove feed rolls are used primarily to feed hard material stock. The round feed rolls are used to feed soft stock and precious metal type stock. If the V-groove feed rolls are used to feed soft stock, pressure from these flats will deform the stock. The round groove feed roll's radius will contour the soft stock and will not deform the soft stock. Both types of feed rolls will deform the stock if the pressure from the stock clamp lever is incorrect. During setup, you will have to change stock feed rolls to match the size stock for the new job. Check your layout sheet for the size stock to be used. Then check your feed rolls to make sure you have the correct size. Make sure the stock clamp lever is in the unclamped position. Next, align this hole in the friction disc with the hole in the machine frame. Insert a pin to stop the upper feed roll shaft from rotating when the feed rolls are loosened or tightened. With a wrench, loosen the hold-down nut on the feed roll. Remove the nut. Remove the pin from the upper friction disc. Insert the pin into a hole on the friction clutch drum. Hold the friction clutch from rotating while you loosen the lower feed roll hold-down nut. Remove the nut. In some cases, you will have to use a feed roll puller to remove the feed rolls from their shafts. Hook the puller behind the feed roll and turn the handle. The feed roll will be pulled off the shaft. You may have to repeat the procedure to remove the lower feed roll. Wipe off the feed roll shafts and mounting area. Inspect your feed rolls for excessive wear. The groove surface may be worn and will not properly feed stock. Mount the lower feed roll onto the feed roll shaft. Make sure that the feed roll size markings face out toward the operator's side of the machine. Install the hold-down nut. Partially tighten the nut. Install the upper feed roll onto its shaft. Make sure the size marking of the feed roll faces out. Install the hold-down nut. Insert the pin back into the hole in the upper friction disc and into the machine frame. Tighten the upper feed roll hold-down nut. Next, insert the pin into a hole on the friction clutch drum. Hold the drum from rotating while tightening the hold-down nut on the lower feed roll. This is the pressure adjusting screw for the stock clamp lever. Pressure on the stock must be adjusted after changing stock feed rolls and stock size. When properly adjusted, the stock clamping lever will begin to clamp the stock at the midpoint of this portion of the machine frame. You should feel the pressure increase as you pass this point. Insert a piece of straightened stock of the proper size into the stock feed rolls and into the tooling area. Try clamping the stock using the stock clamp lever. Notice the point where the pressure starts to increase as you clamp the stock. Turn the pressure adjusting screw counterclockwise to decrease the clamping pressure. Turn the pressure adjusting screw clockwise to increase the clamping pressure. Experience will improve your feel for the proper adjustment. Too much pressure will cause the stock to change shape and cause the stock to bind in the bushing. The finished part size may also vary. This is a 2-to-1 ratio feed attachment. The maximum feed length using the 2-to-1 ratio feed attachment is approximately 1 inch. Located here is the first cam follower. This cam follower will trace the first feed cam. Located here is the second cam follower. This cam follower will trace the second feed cam or the return cam depending upon the job. These are the cam follower lock screws. They are loosened before adjusting the cam followers. The cam followers lock screws are also loosened to remove the cam followers. Located here are the adjusting screws for the cam followers. Turning these screws will position the cam followers. Just below the cam followers adjusting screws are the adjusting screw lock screws. Before adjusting the cam followers, both the adjusting screw lock screw and the cam follower lock screw must be loosened. This is the micrometer stop peg used on the 2-to-1 ratio attachment. The purpose of the stop peg is to adjust the length of the machined part. Located next to the stop peg is this ruled scale. The purpose of the ruled scale is to indicate the feed length setting. The ruled scale is marked 0 to 1 inch. The stop peg is also marked. The markings are 0 to 40. Each line represents 1/2 thousandths change. This is the micrometer stop peg lock screw. Before adjusting the stop peg, the lock screw should be loosened. Before mounting the attachment, the approximate feed length should be set. The stop peg is turned until this edge on the micrometer approximately equals the desired feed length on the ruled scale. The lock screw can then be tightened. Located here is the positive return spring. The purpose of the return spring is to make sure the feed attachment positively follows the return portion of the return cam used. The positive return spring is usually left attached to the machine frame. Before mounting the attachment, the cam follower should be inspected and adjusted. Loosen the cam follower lock screw and the cam follower adjusting screw lock screw. Turning the adjusting screw clockwise will move the cam follower down. Turning the adjusting screw counterclockwise will back the adjusting screw off. You must apply pressure to the cam follower to move it back up. After adjusting the cam follower, this gap between the cam follower and the attachment should be not more than 1/16 of an inch. Repeat the procedure for the other cam follower. Both cam follower tips should also be even. Tighten all the lock screws. The 2-to-1 feed attachment is mounted here to the friction clutch. This lip on the friction clutch must be aligned with this groove on the back of the 2-to-1 ratio feed attachment. Place the feed attachment into position and align the holes for the 2 mounting bolts. Install the 2 mounting bolts. Tighten down both of the bolts. Next, attach the positive return spring to the attachment. The feed length can be found using your layout or part print. The feed length equals the total length of the part plus the width of the cutoff tool. For this sample part, the total feed length would equal 559 thousandths part length, 35 thousandths cutoff tool width. The total feed length is 594 thousandths. This is the 1-to-1 ratio feed attachment. The maximum length of feed using the 1-to-1 ratio attachment is approximately 2 inches. This is the spring return rack. There is 1 spring in each of these 2 columns. The rack slides in these 2 ways in the body of the attachment. Located here are the 2 cam followers. This is the cam follower for the first feed cam and the cam follower for the second feed cam or return cam. These are the cam follower lock screws. The cam follower lock screws are loosened to adjust each follower or to remove a cam follower. These are the cam follower adjusting screws. They are used to position the cam followers. Operation and adjustment of the cam followers are the same as with the 2-to-1 attachment. The follower tips are adjusted to be even, and the gap above the followers is adjusted to be not more than 1/16 of an inch. This is the micrometer stop screw used on the 1-to-1 ratio feed attachment. The purpose of the micrometer stop screw is to adjust the length of the machine parts. Located here is the ruled scale. The purpose of the ruled scale is to indicate the approximate feed length setting. The micrometer is marked from 0 to 80. Each mark represents a 1/2 thousandth change. The ruled scale is marked from 0 to 2 inches. This is a micrometer screw lock screw. The lock screw must be loosened to adjust the micrometer screw. Turning the lock screw counterclockwise will unlock the stop screw. Before mounting the 1-to-1 attachment, the approximate feed length should be set. Use the same procedure as used on the 2-to-1 attachment. This is the micrometer stop peg. The end of the micrometer screw will contact the stop peg at the end of the attachment's return cycle. This will assure the attachment is returned to the same point in every cycle. Located here is the straight rack gear. The rack gear is attached to a sliding column. The rack gear is meshed with a half-circle gear mounted to the friction clutch. The purpose of the rack gear is to transfer the feed cam rises and falls to the half-circle gear. This is the half-circle gear. The purpose of the half-circle gear is to transfer the movement of the straight rack gear to the friction clutch. The circle gear and rack gear mesh. Proper alignment during installation is important. The circle gear and rack gear are a matched pair. When the attachment is stored, the circle gear should be attached to the attachment. If one of the gears becomes worn or damaged, both gears should be replaced as a set. Mixing of the gears from different units may cause improper operation of the attachment when installed on the machine. This is the return spring for the half-circle gear mounted on the friction clutch. The purpose of the return spring is to assure the friction clutch and the half-circle gear are pulled back to its original starting point in each cycle. The return spring is attached to a peg on the half-circle gear. Located here on the side of the attachment are the 4 Gibbs screws. Each Gibbs screw has a locking nut. The purpose of the Gibbs screws are to assure a smooth, even travel of the sliding column in the ways. The Gibbs screws are adjusted to take out any play or looseness in the ways. These are the rack gear holding screws. The screws hold the rack gear in position. Both screws are loosened to adjust the position of the rack gear. The gear is adjusted to mesh firmly, but not tight, to the half-circle gear. This will ensure that the 2 gears do not bind or have excessive play during operation. The half-circle gear mounts to the friction clutch. You must align this lip on the friction clutch to the groove on the back of the half-circle gear. Mount the gear and align the 2 mounting holes in the gear to the holes in the friction clutch. Install the 2 mounting bolts and tighten. Insert a pin into a hole in the friction clutch drum to keep the drum from rotating while tightening the mounting bolts. This is the 1-to-1 attachment mounting base. The attachment is held in position by 4 mounting screws. Attach the return spring to the half-circle gear. Hold the return spring on the gear while you properly align the teeth of the rack and the half-circle gears. The teeth should mesh with the rack gear's last tooth outside of the half-circle gear's last tooth. Push the attachment down and install and tighten the 4 mounting screws. Check the action of the attachment by raising and lowering the columns. The action should be firm and smooth. Located in the center of the rotating tool head is the stock guide bushing. The purpose of the stock guide bushing is to support the stock during machining operations. The stock guide bushing is stationary while the tool head rotates around it. The stock guide bushing extends through the tool head and back to the stock feed rolls. Located here is the lock screw that holds the stock guide bushing in place. To remove the bushing, loosen the lock screw. Next, make sure the tool holders are moved out of position on the front of the tool head. Push the bushing forward and pull the bushing out the front of the tool head. The stock guide bushing is changed to meet the size stock used for the job. Each bushing is marked with the size stock you can feed through it. You must check the bushing with a piece of straightened stock of proper size. The bushing should support the stock with no play between the bushing and the stock. The bushing should not cause the stock to bind or stick. Before installing the bushing, wipe off and clean the bushing and its mounting area. Slide the bushing in and through the tool head. The back of the bushing should not interfere with the feed rolls when they are in the clamped position. Lock down the set screw. Any final bushing adjustments will be done in a later lesson. This completes your television training tape on the stock feed system. You may watch this tape as many times as necessary to fully comprehend the material. When you have finished, return to the operator booklet for your next step.